Hey everybody, what's up? It's Hutch here, and we are on Module 1, Lesson 3 notes. Follow along with me, and if you need help with anything later, please reach out. I'm always happy to help you out. All right, your I can. We want to determine whether quantities in a table show a proportional relationship, okay, by just testing for equivalent ratios. So we'll walk you through that. Your vocabulary today, something really new to you is constant of proportionality. You'll see it's not as complicated as it sounds. Basically, when we're asking for the constant of proportionality, we just want to know what is the multiplier for of like cost for one pizza, or what's the multiplier for how much you earn for 1 hour. Okay, so it's basically that unit rate, whatever number is on top. Okay, that's the constant of proportionality, or sometimes we say the COP, just to be a little quicker with it. All right, so let's take a look at a proportional table and a non-proportional table. So you can start recognizing whether something seems to be proportional, even without doing some work. Okay, so a pizza shop is serving pizzas, and each pizza is $7. I can see that on the table right here. Okay, and so what I want you to do is to see if this table right here is proportional, we're going to just calculate their unit rates. So down below here, I want you to write unit rate. Okay, and let's go ahead and do the unit rates. Now, when we do unit rates, remember, when we're dealing with money, remember where that money goes for unit rates related to cost. Unit cost, the money goes on top. So we're actually going to be doing this table opposite, which happens sometimes, and we're going to do cost per pizza. So our unit rate is $7 per one pizza. Okay, not one pizza, not how many pizzas per dollar. Okay, because that'd be a portion of a pizza. That doesn't even make sense. Okay, so remember to find unit rates, we divide the numerator, and in this case, this is our numerator and this is our denominator. We do 7 divided by 1, and our answer goes on top, and it's over 1, and we do our labels. Okay, so now we're going to do 14 divided by 2, okay, to find the unit rate. And so 14 divided by 2 also is $7 per pizza. And guess what? 21 divided by 3 is $7 per one pizza. And 28 divided by 4 is still $7 per one pizza. Okay, so this tells us that this table is proportional because they all have the same unit rate. And really, that's that same strategy as dividing to check for proportionality. We just wrote it as a unit rate instead. So now there's a different situation. For a single delivery, they're charging an extra $2 if you want it delivered. Okay, so you can see we still have the $7 per pizza, but then they added the $2 delivery fee. And so that's what makes the $9. So we still have 2 times 7 of the $14 in pizzas plus the $2. So that $2 isn't for every pizza though. So even if you have 1,000 pizzas, it's still just plus $2. Okay, a one-time thing for them to drive it to you. So right away, you already know that this is going to be non-proportional because it's not $2 per every pizza. It's just this single $2. So it's going to mess up our proportion. So let's go ahead and prove that and just show it real quick. Again, write the phrase unit rate, because that's how we're going to test if these are proportional. Okay. When we're doing that with money, a unit cost, remember, has the numerator as the money, and the denominator is going to be the other unit. Okay, and so this one is $9 per pizza, per one pizza, because of that extra delivery charge. Okay, now when we order 2 pizzas, 16 divided by 2, now we have an $8 situation per pizza. Okay, let's go ahead and you can do the division for the next ones too. So with 3 pizzas and the delivery charge, what's the unit rate per pizza if we divide it up? Okay, so let's go ahead and look. I'm going to hit clear all. 23 divided by 3, and we have 7.6 repeating, but think about that as money. 7.67 rounded per pizza. And then our last one is 30 divided by 4, and we get 7.5, which as money is $7.50 per pizza. Okay, so you can see the unit rates are different. That means these are not proportional. It's not a proportional table anymore. Okay, all right, let's go ahead and continue testing out some things here. So we have example 1. Carrie earns $8.50 per hour, which is pretty good. Some kids I asked today, and they said they usually charge about $5 an hour. So we want to know, is the amount she earns proportional? And you should already know the answer is yes, because it's $8.50 per hour and there's no other variation with that. So this will be pretty quick here. So for 1 hour, how much money? We just write in $8.50. If it's 2 hours, we're doubling that, right? So that's $17. If it's 3 hours, okay, that's another $8.50. Okay, or you could just do $8.50 times 3 hours now, because that's the unit rate. So you can see $25.50. Okay, and then what is $8.50 for 4 hours? Well, let's see. $8.50 times 4 hours is $34. Okay. And so because there's no extra random things, these are proportional. So let's just go ahead and prove it, because that's what our practice is with this. So write unit rate. Let's just test it out with 2 of them to see. So $8.50 divided by 1, okay, is obviously $8.50 per 1 hour. Okay, and let's test it with one other one, and let's do our 17 divided by 2, which we know is also going to be $8.50 per hour. Okay, and so there's our proof. We have the same unit rates. So is the amount she earns proportional? Yes, it is. Okay, all right, let's check example 2. Right away you can see it's each ticket is $25. There's the proportional thing, but there's this random $6 service fee per overall order, okay, for a single order, not per ticket. If it was per ticket, we'd still have a proportion, but it's not per ticket. It's just on a single order with a variation of tickets. So let's go ahead and test these out. You really only need to test 2 to see if the table is proportional or not, because if 2 of them are not the same, then the whole table doesn't work. Okay, so remember, we want to find the unit rate to test for proportionality. Okay, and so we're going to go ahead and think about how we want to do this. Okay, it's $31 per hour. Okay, so unit rates with money, unit cost goes on top. Okay, all right, so that's that one, and then let's go ahead and test this one here. So $56, make sure the dollar symbol's on the left, per 2 hours. Let's create a unit rate of how much per hour. How do you find unit rates? Numerator divided by the denominator. Okay, and 56 divided by 2 is, we have 25, and then 26, 27, 28. So we have $28 per hour. So you can see right here, this and this are not the same unit rate, and so they are not proportional, which means the whole table's not proportional. Okay. All right, let's go ahead and take a look at a new vocabulary word that I've been discussing with you a little bit, which is constant of proportionality, or sometimes we say COP, okay, as just an abbreviation. So remember, constant proportionality just means what is that number over 1, okay? And so you'll see how this goes. It's really not that complicated, even though it's a pretty long, complicated word. So creators of a stop motion animation can film 24 frames per second. There's my rate, okay? And that's actually the unit rate, right? Because it's over 1 per second. This table shows all their other data. So let's start with this. What is the unit rate? Well, the unit rate is 24 frames per 1 second, meaning for every single second, they can shoot 24 frames. Okay. The constant of proportionality is just asking you, hey, what is that number that I would multiply by to know for every second how many frames can I shoot? So for 1 second, if I multiply by 24, it'll tell me how many frames. For 2 seconds, if I multiply by 24, it'll tell me how many frames. That's that number that they want to know. So the COP, or constant of proportionality, is 24. It's basically your multiplier for each individual second or unit. Okay, so let's go ahead and write this down. It says because the constant ratio is 24 frames per second, the constant of proportionality is 24, and the unit rate is 24 frames per second. Okay, so that's all you do for constant proportionality. Find the unit rate, and whatever number's on top is your constant of proportionality. Okay, it's that multiplier, okay, for each unit. So here we go, example 3. The winner of a jump rope competition jumped this many times in 20 seconds and this many times in 30. So it doesn't say that they're not proportional or to test for proportionality. So they probably both are, but let's go ahead and look. So how do you find constant of proportionality? You find the unit rate every single time. Okay, so let's go ahead and on the side, let's set these up. 124 jumps instead of times, because time sounds like seconds. For 20 seconds, okay, let's find the unit rate. So set it equal to 1 second. How do we find unit rate? Numerator divided by the denominator. So I'm going to grab my calculator. 124 divided by 20. And we get 6.2 jumps per second. Okay, so right there, I found my constant proportionality. That's my multiplier for every single second. Okay, let's go ahead and test the other one just to be safe and make sure we did it correctly. So 186 jumps per 30 seconds. Set it equal to, and write your 1 second underneath because we're making a unit rate to find the constant of proportionality. Okay, and then we can go ahead and do 186 divided by 30, and guess what? Ding, ding, ding. We also get 6.2 jumps per second. Okay, so we verified that they are proportional, and we found the unit rate, which tells us the COP. So because the constant ratio for all of them is 6.2 jumps per second, the constant of proportionality is what? 6.2, and the unit rate is 6.2 jumps per second. Okay. All right, let's go ahead and check out number 4. Okay. It says, after a volcanic eruption, lava flows down the slopes of the volcano. The distance the lava flows is proportional to the time. Sometime, remind me, I got to show you, I have a picture of me. I went on a lava hike, and I asked the tour guide if I could poke a stick in the lava, and he let me. And so the stick started burning up, but then my book bag started sliding down the stick into the lava, and it was insanely hot, but super awesome. So sometime I'll have to show you that picture. Anyway. All right, so what's the constant of proportionality of the flow of lava? Now they're telling us this order though. They want to know meters per second. So the order matters, that's what they want to know, okay? And so we have to look at the order, okay? So take a look, here's meters, here's minutes, okay? So what needs to go first, the 9 or the 5? If you said 9, you're right, because meters has to go first. Now, if you also notice minutes and seconds, they want it in seconds for some reason, okay? So I got to get rid of this minute and change everything to seconds. Okay. So again, my tip to you is just change it all in your data so you don't have to deal with it later. Okay. So 5 minutes is 60 seconds. So 60 times 5 is 300. Okay. 5 times 6 with the added zeros. And then if we do 10 times 6, that's 600. 15 times 6 is 900. And 20 times 6 is 1200. Okay, so now we have our data changed to seconds and we're good to just do our work. Okay, so I need to find the constant of proportionality. How do I do that again? The same way I did the other times. Find the unit rate, and whatever that number is over 1, that's my constant of proportionality. That's my multiplier for each unit. Okay, so let's go ahead and solve that out. But remember, it has to go meters per second. So my top is meters, my bottom is second. Okay, so 9 meters for 300 seconds. What is it? How many meters per second? And it's going to be pretty small because we're taking 9 divided by 300. So let's go ahead and check that out. 9 divided by 300 is 0.03. Okay, so we have 0.03 meters per second. So there's that. Okay, and so I should double check it with one more just to be safe and make sure I did it correctly. So it's sort of like my check to just make sure we're good. Okay, so we'll figure out the unit rate and just double check 18 divided by 600 because I want to make sure we're good. Yep, we're good. It is 0.03 meters per second. So that's my unit rate. Where's my constant of proportionality? Right on top. Okay, so let's go ahead and write our statement here. Because the constant ratio is 0.03 meters per second, the constant of proportionality is 0.03, and the unit rate is 0.03 meters per second. Okay. All right, so here's our apply, and we know that our apply is always a multi-step that is going to have us think a little bit deeper. Okay, so Jalen went shopping for school clothes. It's sort of like if Jace and Braylon got married, they would be Jalen. That's how that works, right? The table shows the sales tax for various purchase amounts. Is the sales tax proportional to the purchase amount? So I just want to know, are these things proportional or not? But this is question 1. So remember, I always like to make these little notes. And then what's the total cost in dollars for a purchase amount of 84? So this is question 2. If they're ever asking you about a bigger number than what's in the table, I always just extend the table and write it in. So then I also don't forget to go ahead and figure out and solve that one as well. Okay. All right. So there we go. Those are our 2 things. First, let's determine if we have a proportional table. So to do that, remember, we can find a unit rate. And if the unit rates are the same, we're good. Okay. We have 2 amounts of money, though. So this visually seems a little bit tricky. What do I put on top? They're both money. So sort of think about it. Do I want to know how much tax per dollar, or do I want to know how much I would purchase per dollar of tax? Okay, so that's what you have to sort of think about. They're both going to help solve things, but typically we'd want to know how much tax per dollar. Okay, how much tax is there on every dollar? So I want to actually have this as my numerator and this is my denominator. Okay, so tax per dollar is my unit rate I want to make. So let's go ahead and set this up. Okay, and so I have 0.6. Okay, and that's my tax per $12. Okay, and so there's my ratio. I want to find a unit rate. So let's go ahead and set it equal to $1. So how much tax per dollar? Well, how do we find unit rates? We do our division. numerator, 0.6 divided by denominator, and we get 0.05, and this is money, okay? So what is that really? It's 5 cents, because the hundredths place is pennies, 5 cents per dollar of tax. And in Pennsylvania, it's 6 cents, so this is a better place wherever this is, less tax per dollar. All right, so let's just check it with one more to be safe. So I'm just going to do the next one. Okay, so we have $1.20 of tax per $24 of purchase. So how much tax on $1? Let's go ahead and do our division to check and just make sure we're good. So $1.20 divided by 24, and yep, we got the same thing. 5 cents of tax per every dollar. Okay, so what's our constant of proportionality for every dollar? 5 cents for every dollar. That means if I have $84, what do I do? How do I find out what that is? Well, it's our multiplier for every dollar is 5 cents. So 84 times 5 cents. So we're going to go ahead and do that times 0.05. And what do we get for right here? Let's check it out. 84 times 5 cents. And we get $4.20, 4.2. Okay, and there we go. Just want to check that one more time. 84 times 0.05. Yep, good. All right, and so there's our answer for the $85. So you're going to do the same thing for your homework. And make sure you're looking at which homework problems match with which example so you can get that extra support. If you need help with anything, let me know and I'm happy to help.